Let's sketch the Lewis structure of NO2, also recognized as nitrogen dioxide. To accurately depict the Lewis structure of NO2, follow these steps. Start by sketching an initial structure. Illustrate chemical bonds between the atoms. Identify and indicate lone pairs on the atoms. Ensure both the central atom and other atoms have complete octets. Conclude by calculating formal charges, aiming for a stable Lewis structure with the least possible formal charges. Before sketching the rough diagram, start by calculating the total number of valence electrons and then identify the central atom. The total valence electrons in NO2 are determined by adding the valence electrons of each atom. Nitrogen from group 15 has 5 valence electrons, and each oxygen, a group 16 element, contributes 6 valence electrons. With 1 nitrogen and 2 oxygen atoms in NO2, the total valence electrons calculation is 5 for nitrogen plus 6 for oxygen multiplied by 2, giving a total of 5 plus 12 equals 17 valence electrons for NO2. To determine the central atom for NO2, prioritize the element with the lower electronegativity at the center. Given the electronegativity values of nitrogen, which is 3.04, and oxygen, which is 3.44, choose nitrogen as the central atom due to its lower value. Consequently, for the preliminary sketch of NO2, position nitrogen in the center and place 2 oxygen atoms on either side. A single chemical bond is represented by 2 electrons. Thus, position 2 electrons on the left side to signify the chemical bond between nitrogen and the first oxygen. Similarly, place an additional 2 electrons on the right side to denote another chemical bond between nitrogen and the second oxygen. In this way, out of the 17 total valence electrons, 4 are utilized, leaving 13 electrons unutilized. Lone pairs consist of electron pairs not involved in chemical bonding, with each pair comprising 2 electrons. With 13 electrons remaining, we will mark 6 electron pairs from 12 electrons, and the remaining 1 electron can be marked as an unpaired electron on the structure. Additionally, it's essential to note that both nitrogen and oxygen are period 2 elements, limiting them to holding a maximum of 8 electrons in their valence shell. Another important point to remember is to start marking lone pairs on outside atoms first and then on the central atom. In NO2, each of the 2 outside oxygen atoms will receive 3 lone pairs, while the central nitrogen atom will get 1 unpaired electron. It is evident that the octet is complete for the outside oxygen atoms, but not for the central nitrogen atom. Therefore, let's focus on completing the octet for the central atom now. First, recall that nitrogen is a period 2 element and is limited to holding a maximum of 8 electrons in its valence shell. Initially, nitrogen possesses 5 valence electrons and requires 3 more to complete its octet. To address this, we will relocate 1 lone pair from the left oxygen atom to nitrogen, forming a chemical bond. While this adjustment ensures that the 2 outer oxygen atoms have satisfied their octets, it is apparent that the central nitrogen atom does not achieve an octet. However, considering nitrogen's valence shell limitation, we cannot further convert a lone pair to create a new bond with the nitrogen atom. Now, to check the stability of the structure, let's proceed with calculating the formal charge. This is the formula we can use to calculate formal charges for the NO2 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and allocate the values to determine the formal charges for each corresponding atom. For nitrogen atom, valence electrons is 5, non-bonding electrons is 1, and bonding electrons equals 6. So the formal charge will be equal to 5 minus 1 half times 6, which is equal to +1. For left oxygen atom, valence electrons equals 6, non-bonding electrons is 4, and bonding electrons is also 4. So, the formal charge will be equal to 6 minus 4 minus 1/2 times 4, which equals to 0. For right oxygen atom, valence electrons equals 6, non-bonding electrons is also 6, and bonding electrons equals 2. So the formal charge will be equal to 6 minus half multiplied by 2, which equals -1. The formal charges of both nitrogen and oxygen atoms are mentioned, indicating that the current structure has formal charges closer to 0. Therefore, this structure represents the preferable and most stable Lewis structure of NO2. To represent a pair of bonding valence electrons, we can use a single horizontal line. Since there are two pairs of electrons on the left side, draw two horizontal lines on the left. Similarly, draw one horizontal line on the right, indicating that nitrogen is double bonded with the oxygen atom having two lone pairs and single bonded with the oxygen atom having 3 lone pairs. So that's the Lewis structure of NO2. If you found this simple explanation helpful, press the like button, share the video, and subscribe for more.